Researchers have a tendency to fall in love with their ideas, and because they are smart people and intellectual, they believe in what they are doing, and sometimes they may ignore the response from the world. Could be from the market, from customer's customer. What are the alternative approaches? What are the competing technologies? So we need to constantly calibrate our work by understanding what impact we are going to have on our customers, and you cannot assume that impact. You need to go and talk to them. You need to go and get their feedback.
Hi, everybody. Good afternoon, good evening, and good morning, wherever you are. Thank you very much for joining the Boredom Club today for another episode. So today we are fortunate enough to interview none other than Dr. Ahmad Bahai, CTO of Texas Instruments, the global semiconductor powerhouse that revolutionizing how the world connects, senses, and processes information through innovative semiconductor innovation. So Ahmad, thank you so much for joining us today.
Good morning. It's a pleasure, and thank you for taking the time to host me.
Absolutely. The pleasure is all ours. So, Ahmed, I want to start with a quick questions about your founding background, because you founded Algorex before it got acquired by National Semiconductor, which I think just within a few months got acquired by Texas Instruments. So if you're looking back, what was the most difficult founder lesson that you had to learn when transitioning from sort of like a startup mentality environment to a place like Texas Instruments with all the side of it?
So maybe I start from a little bit earlier time of my career. For after my graduation, I joined Bell Labs, and Bell Labs back then was the place to innovate, work with the most innovative people, brand names in the technology, from semiconductor to communication to optics and everything in between. So it was really a great environment for a fresh graduate student, a PhD student graduating from school, to go to a place that is unique in the sense that you're working with the icons of the technology. So I really enjoyed my time there, and a lot of great ideas and engagements with many scientists and technologists there helped me to appreciate the value of innovation. After Bell Labs, I started my own company, which was focusing on acoustic and wireless communication, hiring some of the best names from Bell Labs and the rest of the industry. And we, of course, going from a very big center of excellence in R&D to startup is a big transition. You can imagine in startups, you're always on your toes, in the sense that you're one step away from success or running out of resources and funding. So you need to keep running and moving and making sure that your innovation has some traction in the market. And after almost 2 years of the startup, the company was acquired by National Semiconductor. So again, a transition from startup back to big company. And the contrast is amazing. I mean, in a startup, you need to be always paranoid about the fact that you have to make it, you have to innovate, and you have to make sure that there is attraction. And pretty much you have to be jack of all trades, from securing funding to working on technologies to managing people and everything in between. It's an exciting experience, and in some cases very rewarding, both in terms of innovation and in terms of opportunities. After moving to National Semiconductor, National is one of the earliest and largest companies in analog and mixed signal back then. And I enjoyed the fact that now you have a lot more critical mass and stability. But of course, there is very different mode of operation in a big company compared to startup. So the contrast was very clear. You need to kind of work with a lot of people on multiple angles of the projects. The pace of projects are different. The structure of the company is well established. So very different environment, but also enjoyed the time there. And after a few years, I ended up being CTO of National Semiconductor, and Texas Instrument, which was back then even the largest analog mixed signal company, acquired number 3 or 4, and the joint forces of TI and National created the absolute leader in the analog and mixed signal, and I've been CTO of Texas Instrument since then.
That's fascinating, to say the least, and very hectic, I believe, as well. And I also read that you maintain deep ties to the academia, right? MIT and Stanford University. But I was curious to ask you, how do you ensure that there's sort of like the blue sky research happening in the university labs actually survive and become relevant either within Texas Instruments or maybe even other companies out there?
That's a very good point. During my career, I always had some engagement in universities. I was at UC Berkeley as a part-time faculty for many years, and then at Stanford as a part-time faculty, and now at MIT. And I really found it very rewarding in multiple ways. When you go to universities, you are dealing with an environment that a lot of young, talented people who are looking for next great ideas and a lot of energy and passion and the drive. So you can work with people who really are at the earliest stage of their career or their education, and they want to make an impact. So you can get inspired and you can inspire them both. But also, as you pointed out, there are a lot of interesting research in universities which need to be tied to reality of what industry needs. Because in many cases, research in universities and what is needed in industry there is a gap in between that really requires a lot of engagement and collaboration. And the reason is very obvious because university's charter is pushing the envelope of the knowledge and technology, not worrying about manufacturability or not worrying about production. Whereas industry wants technologies and ideas that are manufacturable and can be mass produced and bring a lot of revenue for the company. So very different objectives. So obviously there has to be some interaction, there has to be bridge in between, and that bridge can happen, at least from my experience, by being there on the ground on both sides and try to build that bridge in person. There is no prefabricated bridge that you can put there and have a channel of ideas coming from university to industry or vice versa. You have to go there case by case, cultivate this kind of relationship, work with people, and you end up with hiring and getting a lot of top talents, and many ideas can end up being a recipe for success in the industry.
I think we even seen it now with all the researchers of AI that essentially coming from the academia, and it seems that the same thing is going to be with quantum computing with all the qubits out there. So it's definitely a fascinating time in both places. And I want now to shift the gears a little bit to Kilby Labs within Texas Instruments, the place where all the magic happens, right? But you build disruptive products, but I guess there are many ideas there. How do you decide if an idea is enough moat in order to be disruptive rather than a product feature at the end, and maybe it doesn't worth all the spending in R&D and so forth?
That's also a very important point because Kilby Labs in TI plays an important role to kind of build the momentum and pipeline of ideas which are risky for a product line to adopt. So in many cases, we see that the idea can have a potential market value, but the technology might be risky. Or in some cases, technology might be there, but the market is not there. So the level of risk might be too high for a business unit because business units are measured by revenue in the short term and midterm. And if you take too much risk, you may distract your profile of the products and revenue, and that could be consequential. So we felt that we need a organization that works with business units as well as customers, as well as universities, to identify those risky ideas that have enough potential for changing the market or creating a new market. So de-risking is very tricky business in innovation because you don't want to spend too much time on ideas without getting feedback from your customer or your customer's customer. Because researchers have a tendency to fall in love with their ideas, and because they are smart people and intellectual, they believe in what they are doing, and sometimes they may ignore the response from the world. Could be from the market, from customer's customer. What are the alternative approaches? What are the competing technologies? So we need to constantly calibrate our work by understanding what impact we are going to have on our customers. And you cannot assume that impact. You need to go and talk to them. You need to go and get their feedback. But again, that even is tricky because sometimes you need to understand what their needs are, not necessarily just immediate needs, but midterm and long-term needs. So by tying these points together, by tying these understanding of market, technology, competition, technical risk, you can structure environment that de-risk the project but not over-invest without better understanding of what's going on. So you need to do that at every step of the work. So when people ask me how much resources you put on a project and how do you manage the risk, I said the risk and resources are inversely proportional. The higher the risk, with the lower resources you're putting on that to make sure that you're de-risking at the earliest stage. And the more you manage the risk, you add resources to take it to the next step. So you need to have this formula and mindset to adaptively calibrate your R&D pipeline with the reality of what's going on in your field and industry.
I agree. Specifically, what you said about don't get fall in love with your products. We spoke with a lot of startups, and I don't think there was even one of them that have not done any pivot along the way from the initial product. So it's very resonated with me. And okay, can you tell us maybe about any explosive breakthrough currently sitting in Kilby Labs, or something that has been in Kilby Labs and went out to the world that you wish to share with the audience?
Yeah, absolutely. So over last many years, we worked on technologies that really are, technologies that which we think it was very important for a wide range of applications. Because one thing about Texas Instrument that I'm sure you're aware of is we have this broad market presence, meaning that our products and our technologies can be used in a wide range of applications, from robotics to satellites to data centers and everything in between, ranging from power, from the embedded processors, signal path, and everything in between. So for many years, we worked on several technologies which really pushed the envelope of the performance, but also critical for the wide range of applications. For example, we had a project, we started it several years ago, on how to come up with a new clock generation device that can outperform any crystals or anything that is out there today. Because today, almost all clocks on every electronic board, from a data center to your phone, there is a clock generator that is usually a crystal, that crystal that resonates and creates a clock reference. So we thought that maybe we can have a better understanding of how to come up with a MEMS structure to create a much cleaner clock. That would be very valuable. And the insight was very clear. The data rates are going up, the communication is getting faster, and you need cleaner clock to send the signal around the board. So we came up with this idea of how to design a bulk acoustic wave resonator to offer a very clean clock. The journey was not very smooth. Like any innovation, journeys are not very smooth, because if it was smooth, everybody would have done it in before. At advance. So one day everything was working, next day nothing was working. So we had to go through redesigning the device, come up with ways to fix the problems. But a couple of years ago, we managed to get it to the point that is ready for production. And guess what happened? Is now getting adopted so rapidly. In data centers, they are now using our clock, which is bulk acoustic wave bulk clock, for high performance, low jitter references. It's being used in a wide range of aerospace and defense. So we see that this technology that at the early stage was almost like impossible per se, now is becoming a game changer in timing a clock. We had another project that we called it, and it's announced already, for isolation. Isolation is a technology that really separates two domains of the signaling, low voltage and high voltage, or even some different domains of the circuits on a single chip. So we felt that isolation is becoming extremely important, because you need to control these high voltage circuits in your electric car or in smart grid or power management for data centers with these microcontrollers, and they need to have different islands of the voltage and current. So we came up with this isolation technology that is on-chip isolation, that can provide this separation of the domains of voltage on a single chip or in a single package. And this has been extremely successful. The idea was at the earliest stage, again, something that we thought, it has some opportunities in some specific markets. Then we realized that it has much wider application. So these are among technologies, or high voltage transistors, GaN, or things like that, that we started at the early stage in Kilby Labs, and now it's becoming the dominant technologies in many applications. across different markets. So it's really exciting. And the radar one is another one. We started radar at the early stage for some specific applications, automotive. But now we see that these radar chips are becoming so dominant in everything, from drones to everything in between, from inside cabin of the car, sensing, motion sensor. So again, the concept that was very risky, both in terms of the technology and possibly market, ended up being a very successful thing. And also, we are proud of a lot of stuff that we didn't do, meaning that at the early stage, we decided that, okay, it doesn't make sense to put a lot of resources on that. So we changed the direction on that one. So we are very proud of things that are making a big impact, and also things that we decided not pursue because of the fact that it was too risky, or the market or technology had a lot of unknowns in front of it.
It is exciting. I can tell you, I was in the academia as a student, and I remember just like using Texas Instruments calculator, but at the same time, people also using inside the data center, the innovation of Texas Instruments. So the span of product is incredible. And I want to touch on another innovation that you just introduced, the world's smallest MCU.
Yes.
And it's interesting because it seems that the world obsessed with bigger AI and more power. I mean, we just saw Cerebras going public with a chip in the size of a dinner plate. But I'm curious to ask you, why Texas Instruments doubling down on tiniest application, and what does this actually tell us maybe about the future of ambient technology?
That's also a very relevant and interesting point that you raised, Yossi. I think, as you know, intelligence and AI is permeating every aspect of our lives. I mean, these days, every major conference, every universities, every news about the market has to do with AI and technologies. I mean, it's amazing the AI is pushing technologies envelope very quickly in every aspects of it. I think in the future, of course, data centers are going to play a ever increasing role in doing this cloud intelligence, meaning that training based on this massive amount of data and massive amount of processing, which is extremely critical and very exciting. And that is pushing the technology in many fronts, on the processor side, on the power delivery, on the timing and clock, on interface. So we are heavily present in that area. But also, we see that intelligence is permeating everything else, from your laptop, which very soon is going to have a GPU or a kind of processor that is doing a lot of analytics, to your phone, to your watch, and to many other sensors. So the intelligence, I call it hierarchical intelligence, meaning that you have this massive amount of processing and data at the cloud, but also you have some level of intelligence as you work on the edge. I mean, that could be edge like your car, the robot, your laptop, or extreme edge, like your watch or your sensor on your ring, in your on your finger, or something like that. So the level of intelligence goes in both directions. And why is that? Because in many cases, you need to make a local decision. You cannot go for every decision to the cloud. You need to make a decision. Let's say if you are driving a car and you have an instant of something happening in front of you, you cannot rely on doing everything on cloud. You need to do some local processing of the data, and so local intelligence in your system. Same thing for your phone, same thing for your sensors. So we are strongly in favor of having this presence across the board. We are playing very strongly and very intensely on data centers. We are increasing our investment of technology and development there, but also we are looking at intelligence at the edge, which are these tiny processors that you're talking about. These are MCUs that are 1.25 millimeter by 1.25 millimeter, and some of them have also an AI accelerator built into that, meaning that you have an AI accelerator on a tiny chip, because that tiny chip can sit on a tiny motor in a robot or in a sensor that is detecting motion or something like that, and needs to analyze data at the local level. So we see that while training is happening at the cloud, the neural networks need to be also processing data as part of your local signal processing on the device at very low power, low cost, affordable, and high performance. And that's why we are focusing on providing that kind of capabilities for a mass market, as I said, what you call it edge AI.
The Edge AI, it's incredible what it's going to be specifically, I guess, with robotics and physical AI, and people say maybe even a data center in space. So I guess it's sort of like an edge out there. And okay, people also talk about AI, right, with Cursor, Codex, and other tools. It's much easier than before to do some coding. But I guess I wanted to ask you, as the CTO, you're leading all of the engineering organization within Texas Instruments, how you prevent your engineers from maybe over relying on models and just like keep this intuitive spark that led to some of the biggest innovation that we've seen in the last few decades?
AI has impacted every aspect of engineering, design, and even education. Many are talking about AI at some point of time get so efficient and strong that can do a lot of things autonomously. But one thing that is interesting to understand is that it's not something that happens overnight. I mean, look at autonomous driving, for example. Autonomous driving, everybody was talking about it almost 10, 15 years ago. It took
Right.
us 10 to 15 years to get to some level of autonomy now. And still, it's not fully, I mean, in highways, you don't see all autonomous cars. I don't know how many autonomous cars you see on highway today, and we have been talking about it for 10 years. So what is happening in that field, cars are getting a lot more intelligent and it helps the driver a lot more. You can see things around you that you don't see just by naked eye through these radars and cameras and so on. You can see you can get a lot of intelligence from the car. So what I see in many cases, AI is becoming a great co-pilot. Now, over time, I'm sure it's going to change, but it's not a scale of next year or next 2 years. Look at again, autonomous cars. It has been a 10 years journey, and still we are making progress every day. So I would say, an engineering side, the same thing. AI has been extremely helpful tool to make the life of a designer a lot more efficient and productive, in the sense that now you have access to massive amount of intelligence on your side. Now, could it at some point replace a designer or a coder? We cannot say how long and how far you need to go to get there. But today I can say that with AI, we can increase our efficiency and productivity significantly. I mean, look at just basic things. Now, when you want to do a search, in the past, you take a search engine, you type a word, and you get like 500, different references. Now, you type a sentence, and it gives you a summary of all those searches in one shot. So you can see how much productivity has increased. Same thing in design. Let's say if you are designing a circuit, in the past, myself as a circuit designer, you rely on your experience and knowledge, what you learn and what you have seen. But now you can build it on experience and knowledge of hundreds of thousands of other designers in these databases and see how they approach the problem. So that can improve the efficiency and productivity significantly. But still, that intuition that you pointed out is playing a role. So I would say at this point, AI in design and education is a great co-pilot, and it's becoming more and more influential in terms of productivity and efficiency. What's going to happen 10 years from now is an exciting time. It's hard to predict.
No, absolutely hard to predict. No, nobody really knows. Otherwise, all of us would be rich, right?
That's
And
right.
and I guess also with AI now, just the time to market, and specifically in semiconductor, you innovate something, but it could take only 5 years until you really see it in practice. So maybe it could save some time there. And I wanted actually to touch on this point. So when you work with all of your engineers, I guess you have an idea, your engineers have an idea, but it could take time until you see it in practice, right? In the market. How do you motivate them? In terms of like, okay, let's work on it, but we'll see the results only like 5, 6 years. So,
I think, especially in big companies, you'll see there is a pipeline of projects. So it's not like everything starts today, waiting for
all
five
right.
years from now. There are things that started 2 years ago and 3 years ago and 4 years ago. So we have this pipeline of innovation and ideas that, at the early stage, you need to make sure that it's well balanced, meaning that you have an understanding of what's happening short term and you're investing on the long term as well, in a careful balance. And once you have this pipeline, I think my experience of professional life is that you need this passion and curiosity. that if I can make this happen, it's going to change the world some way. And
Right.
that drives you every day. Some of the projects that I've been involved and now I see it out there making an impact in people's life is satisfying. So there is intellectual satisfaction, there is an impact satisfaction, and this pipeline is getting more and more balanced in companies like TI because we have such a wide range of technologies and wide range of customers. So one day we talk to a car company, next day to a robotic company, third day to a data center companies. And we need to understand how we can change these markets with this wide range of technologies that we have in our toolbox.
So it's all about curiosity. And I do have one last question before we go into the rapid fire questions. So actually your recent agreement to acquire Silicon Labs, right? Making a massive play for the invisible infrastructure that we mentioned before for all the IoT out there. But how this acquisition maybe changed the roadmap for Kilby Labs? And is it sort of like a foundational shift in how you approach wireless connectivity on the edge or not necessarily?
So the couple of comments, as you know, TI is a unique company, the leader in analog mixed signal, which offers design, manufacturing, assembly, and selling all in under one roof. So we invested significantly on expanding our manufacturing capabilities. I'm sure you have heard it, billions of dollars on new fabs and new facilities, state of the art in analog and mixed signal. So obviously, when we see a compatible company or technology that can leverage our manufacturing, we see that as an opportunity to add more value, meaning that combining the excellence in design with efficiency of the manufacturing and the infrastructure that we have around the whole thing. So as I said, from design to assembly to test to manufacturing to selling and distribution, everything. So we see that some of these, like the recent acquisition, definitely is a step in that direction. But also, as you know, everything around us is becoming connected and smart. Everything
Right.
from the ring that you're wearing on your finger, or the watch that you're putting on your wrist, or the phone in your pocket, or the car you're driving, or your refrigerator that is talking to your washing machine and to your phone and everything else. So you can see connectivity is becoming so pervasive that everything around us, every single device has some level of connectivity. And we see that market is growing. So acquisition of the Silicon Labs is a step into building more credible technology and footprint in the IoT connectivity, but also foundational technologies for communication that we can leverage in our fabrication facilities and manufacturing capabilities.
It's very exciting industry, specifically in this time, to say the least. And okay, so I want now to move on to the sort of like rapid fire questions, but you could take the time to answer. So first question, maybe the most interesting one of them all. I've heard that you're a formidable chess player, right? And how does it influence how you navigate a 10-year product life cycle? Do you get some advice from your chess mentality or?
I think there are multiple learnings from playing chess to kind of positioning your technology and market development. One is that, of course, you have to be highly creative and curious. Second thing is that you need to be highly adaptive. And it goes back to our earlier conversation. You may come up with a plan and a target, but in a year, you know that either market shifts or technology shifts. So you cannot just say that, okay, I ignore that and I keep going. You need to adjust to that, like a chess player. Depending on how the other player is moving the game, I mean, you have to react to that and making sure that you react to that in a very intelligent way. The third thing is that you constantly need to get feedbacks. Now, that's different from chess because you cannot talk to anybody else while you're playing chess. But in this case, you have to get feedback from your customers, from the market, from technologies that are, because in the span of 5 to 10 years, a lot of surprises are going to come up that can change the whole landscape. So you think you're working on a technology that is absolutely the only option for clocking or for power switches or for whatever. And 3, 4 years down the road, a group of smart people somewhere in the world come up with an alternative that you are not even aware of. You cannot just ignore it and say that, okay, I keep going. So you need to be highly adaptive, reactive, and you have this 360-degree kind of view of what's going on in the field and calibrate yourself accordingly. So my favorite analogy, Yossi, is that you start from point A with point B in mind, but you end up on point C, which is a lot more exciting than point B because it's very zigzag kind of journey. I mean, you have to move, you have to change direction, but you need to have the understanding, focus, and intention to make it a success story on technology and the markets. And I have many examples that we can go hours and hours to talk about it. Yeah.
So what I will take is always look out for the queen, specifically in chess and in technology.
Absolutely.
You never know what is going to attack you from which direction.
Exactly.
Okay, and I've heard also that obviously you are a CTO, but you also hold something like 40 patents under your name. Was there anyone that you're most passionate about, or let's say was the most fun to solve?
Actually, there are quite a few of them that I'm very excited about, but the one that I see regularly when I walk in the streets is that some of the medical devices for wearable that we designed, now I see that on people's arm and people using it every day and changing their life and making an impact on their health. That gives you the satisfaction that, okay, we were involved in this technology and here is how it's impacting people's life and completely changing the landscape of the health and personalized care.
That's incredible. And mentorship. Do you have any mentor that you would like to mention, or maybe even mentorship advice that you would wish to share with the audience?
I think mentorship in technology companies and science and research is extremely important because usually you hire fresh talents with a lot of energy and excitement. And that means you have this huge stream of the water coming in. If you don't channel it right, it becomes destructive sometimes other than constructive. So for example, many of these fresh graduates that we hire, they have a lot of ideas, fresh ideas, creative ideas, but sometimes ignore some of the reality of complexity of making it manufacturable or practical. So combining the strength on or experience of a mentor with the energy and the talent of the fresh starter is an amazing, powerful engine because now you're combining the drive and the direction. I mean, I call these top talents a strong engine, but a mentor is a steering wheel that can help you adjust where you're going. So if you just go fast and you don't know where you're going, it's not going to be very effective. I mean, so you need to combine the energy of fresh talent and capability and ideas with mentorship and experience that people have been around. Because also, on the other hand, mentors usually, because of their experience, they are more cautious. So they need to have these fearless people work with them, not being afraid of failure, but also leveraging the learning and know-how that is have been accumulated over many years.
100%. And if you had the chance to grab a coffee with anyone, could be historical figure, could be, I don't know, someone from the movies, who would it be?
I would love to spend time with people who really changed the world and their impact on the world is very clear. And there are many examples, I'm sure. And I've had the luxury of working with these people through their innovation, they changed the world. For example, I had just meeting last week with somebody who started this quantum dot concept from the beginning and now is changing
Wow.
impact of every display, every and we see on a wide range of technologies. So people who change the world through innovation are really fun to talk to.
Specifically quantum, I mean, just like the idea of qubit, to be sort of like in two places at the same time. It's very revolutionary in terms
Fascinating.
of cryptography. Yeah,
Yep.
it is fascinating. And okay, hobbies outside of work. I know that you're super busy leading
Sure.
Texas
Okay.
Instruments, but
My hobbies are really more like reading about the technology and history of technology and people who impacted the world. I really am into workout and anytime that I can find from my work to do some exercise, going to gym or do something that really pushes my body, not only my mind, but also my body. I found it very helpful because it's not just keeps you healthy, it keeps your mind productive also. I mean, somehow it gets the blood flowing better and you get more ideas coming out of your head by doing some some workout. So I'm a big fan of doing workout and reading a lot. I mean, even if it's not technical.
Maybe last question, and the hardest one of them all. What is your favorite movie of all time, or maybe even favorite book?
My favorite movies and books actually both are on the category of the history of people who were very impactful again. For example, started the company and then they changed the world, or started a field, or I mean, Edison like people who really changed the
Yeah.
world through innovation, because that gives you a sense of how much resilience and perseverance and hard work it takes, because this new generation sometimes feel that these great ideas just come to your mind in the shower. It's not like that. You have to do a lot of hard work and maybe many failures before you get to success. So reading about those people or watching movies that are showing that kind of challenge in the life and the outcome of that is really inspiring and entertaining.
I would love to actually grab a coffee with Thomas Edison or someone like this. Would be fascinating.
Exactly. And there are many contemporary names that have the same level of impact. So, and I've been lucky enough to spend time with them, and it's really enjoyable.
Absolutely. So, Ahmad, thank you so much for joining us today. It's been really a joy and very honest conversation. So, thank you so much for joining us. And for everybody else in the audience, so stay tuned. We have other interesting episodes from the president of ServiceNow, president of Cisco. So, stay tuned and watch the shorts and video of this one. So, thank you
Thank you
so much.
so much. And it was a pleasure talking to you.